Let's take 15 people, of which we have measurements of their heights in centimeters, and build a relative frequency distribution using 5 classes. So we'll do this as a T-chart and as a histogram. All right, so we've already established that if this is my data, the lowest is 143, the highest is 179. So if we go from 140 to 180, that should capture all of the data. And if I want to put 5 classes inside this distance, then each class is going to take up 8 units of space, or 8 centimeters. So we'll have our classes here, and then we'll have the relative frequencies here. So the relative frequency distribution is going to have the exact same shape as the original frequency distribution, but now it's just going to be normalized by the size of the data set. So we're going to normalize it by the 15, the number of people whose heights we measured. So let's organize this. First, let's give ourselves the classes. If we start at 140, we need to go to 147.9. The next one will pick up at 148 and go until 153.9, 154 to 161.9, 162. Oh, nope, I think I messed up. Right, because that's going to end at 170, and if I add 8 to that, that's 178. That's not 180. Where did I go wrong? That's a distance of 8. Oh, that's only a distance of 6. Okay, there it was. Okay, 148 plus 8 puts me at 156. So we'll go to 155.9. This one will pick up at 156 and go on until 163.9. This one will pick up at 164 and go until 171.9, and then 172 to 179.9. All right, so those are my 5 classes. They each have a class width of 8. And now we just need to distribute our data. So how many data points out of the 15 are inside the first class? I see only 1. So there's 1 out of the 15. How many data points are in the second class? Up until 155.9. I see 1, 2, 3, 4. So there's 4 out of the 15. Right, this is why it's called a relative frequency distribution. We're comparing how many are inside each class to the total number of people that we took data from. Our third class, 156 to 163, how many does that have? We've got 1, 2, 3 of the 15. In the fourth class, 164 to 171, that's going to give us 1, 2, 3, 4, 5, 6 out of the 15. And then 172 to 179, there's only 1. Oops, what's happening? 1 out of 15. And let's just double check that we haven't counted data twice, or we haven't left off any data. This should sum to be 1. Right, if we add our numerators, 1 plus 4 is 5, plus 3 is 8, plus 6 is 14, and then plus 1 is 15. So 15 out of 15, all of our data is taken into account. And if we represent this as a histogram, we put our relative frequencies on our y-axis and our classes on the x-axis. Now, the maximum is going to be a 1, right? Because nothing over here is greater than 15 over 15. So what can we say? 1 out of the 15 are inside class 1. So 1/15, 4/15 for class 2, 3/15 for class 3, 6/15 for class 4, and 1/15 for class 5. So you can see that it has the exact same shape as the original frequency distribution, but now it's just normalized. It gives us a relative frequency for each class. So how many data points are inside each class compared to how much data you took.